Today's curiosity is assisted by Black Mass Black Pilsner from Barnhammer Brewing in Winnipeg. Their tasting notes include words like velvety, dark chocolate, and toasted. And 25 cents from each can is donated to One Just City charity. Nice. So today I'm taking a look at this little inverter that I picked up at a yard sale last summer. There's absolutely no information on it. Well, other than it takes 12 volts DC in and puts out 110 volts on the output. And apparently it's QC passed. That quality control does not include this crimp job on this wire here. So on top of it, we have an on-off switch, a couple of 7-segment LEDs, presumably for the voltage and current or something like that, 4 USB-A outputs, and then these two universal-ish looking beasts. They'll take North American, they will take European, presumably with that there they will take the UK plug, although this thing only puts out 110, so it'll only work for things that have universal inputs, universal voltage inputs, such as this little power adapter here. For something that's only putting out 110, I don't know why they even bothered to put that connector on there. Whatever. What else do we see? Oh, there's a couple of lighter plug outputs there. No, that won't get you infinite power if you do it that way, but I guess that gives you a pass-through since you're taking up your thing there. Let's just fire it up and see if it actually works at all and what we can get out of it. So I've got my larger power supply set to 12.5 volts, 6 amp current limit, which is the maximum that it can do. Connected oh so securely like that. So let's see what happens when we turn this on. Oh, I left it on there, okay. So just with no real load on, just drawing about 0.5 amp for the noisy fan, I guess, and just the transistors and whatnot that's going on inside it. It is putting out 113.8 volts, so that's quite reasonable for North America. 58 hertz, that's not ideal, but most things won't care. If you plug a clock into it, it'll run slow, I guess. And on here we have, I guess, 12.4 volts DC input, probably, and 118 volts out. Not exactly what that says, but I guess close enough. Wow, that fan is loud and annoying. Let's plug some stuff into it. Here is a 40-watt incandescent light bulb, drawing 300 milliamps. But on the DC side, it's drawing about 3.5 amps already. Wow, that's not at all efficient. That's 34 watts that it's measuring out of a 40-watt bulb, so I guess that's reasonable enough. Let's try it with a 60-watt bulb. That's showing 50 watts there. We're drawing almost to the current limit on this thing. Actually, it looks like it is current limiting. See that bottom LED there? That is the current limit light. Hasn't drawn it down all that much though. Although, yeah, it has drawn the AC voltage down to 108 volts, which it's confirmed there. And since this thing is still running within its limits, I'm going to say that's pretty close to the edge of what it can do. Let's just see what we're really drawing here. 4.8, 4.9 amps. Okay. We can probably go a little bit higher, although I don't know about that. Let's try a 75-watt bulb and see what happens. Ooh, it's chirping. It doesn't like that. Yeah, that's not working out very well. Although it's still within range for voltage there, but that's not happy. 75-watt load is the most that it can handle. That's not a lot. I guess one more thing before we open this thing up. Let's see what the waveform looks like. Not expecting much out of this thing, but you never know. Oof, yeah, that's not ideal. 75% duty cycle and pretty much straight up square wave. Yeah, not happy with that at all. So, yeah, that's about all we can learn from this thing without taking it apart. So let's just get into that. Might as well start by taking the wires off the end here. At least they were crimped and not just wrapped around with loose strands kicking out all over the place. That's nice. This is less nice, but whatever. It appears to get into it. I have to take the end panels off. I'm assuming one end panel will just take this off, and then the other end panel will allow the whole shooting match to slide out the guts. Maybe, probably. We'll find out in a moment here. So what happens? Not much. Why doesn't that want to... Eesh. There's a spark. Oh, okay. That top comes off. Right, well that makes it easier. I'll just undo this side here. Actually, if that top comes off, does the bottom come off too? No, it doesn't look like it. Pop these other two screws out this end. I'm not sure if you noticed it or not, but I actually got a spark off something inside when this shell of this connector shorted against something, so it tells me that there is not a discharge resistor on at least one of the capacitors in there, so this could be exciting. Okay. Which way does that want to go easiest? There is no way that it wants to go easiest. Right. So up on top here, we have a small circuit board which has the USBs. Oh, we didn't even test those USBs. Remind me to do that later. We've got the USBs on there and the 7-segment displays. There is the power switch. That is hot glue. Really inspiring confidence, guys. Here are these universal fits nothing properly output jacks. They do have shutters, so I guess that's something. That'll make the UK guys happy. But as you can see, there's no earth or ground on there. It's just the hot and neutral. So, what do we got down here? Oh, plugs. Okay, so power switch goes onto a plug down there. The little board goes onto a plug down there, and the AC outputs go onto a plug down there. Yeah, that makes it a lot nicer to deal with. So, these are just 12-volt outputs, which you would expect would be in parallel with 12-volt inputs, but I don't think they are, being as how, like I said, I got a spark off those when I splashed them against something. Maybe against that switch? I'm not sure. I'm just going to pull these last two screws out and get this input side out of the way, because I think it's going to be a real pain to get the main board out because it's connected through all the heat sinks of all these devices on both sides. I'll probably do it anyway, but okay, now that comes out here. We've got a power plug for the noisy little fan. Got a couple of fairly heavy input wires. That's nice. Then we have two fuses down there. Looks like two 30-amp fuses. They're soldered into the board, so even if they blow, you can't get them out. But they look like they're in parallel, which would mean they're pretending to be a 60-amp fuse. Well, this thing is getting more and more entertaining as I look at it. So here are a set of 6 power devices, probably transistors of some sort, and they have little insulating, presumably thermal conducting sleeves on them, and then each pair of them is held in by a bar there, which goes to screws on the outside. Over on the other side, we have 4 more of those, and that is what's holding this board in place. So I guess that's what I'm going to have to do to get the board out. And I'm hoping that everything in here is discharged now. I suppose I can test that by doing this. Yeah, nothing happens there. Nothing happens there. Where else can I short to get rid of power? I don't see anywhere else that I can get at least not until I get to the bottom of the board. So I will resume this. And with that all out, this should just all slide free of here. I'm still a little bit scared of that main board. But there we go. Let's just deal with these capacitors to make sure that there's nothing that's charged. Where is more capacitors? There's one over there. Okay, I think we're all discharged. I think that should be safe to handle now. So there's a 12 volt positive input. There is 2 fuse holders in parallel, like I thought. There is a capacitor across the input for 4700 microfarads, 25 volts. Big guy. And then these transistors over here, the set of 4, looks like those 2 are in parallel, those 2 are in parallel, and they are driving one side of that transformer. Yep, pretty much directly from the DC. I'm not sure where the base and or gate of these things is coming from yet, but odds are pretty good it's going to be one of these guys here, I'm thinking. Meanwhile, the negative voltage, the negative side of the 12 volts, comes into here. So it goes to that pair of transistors. That's some of the 6 transistors on the other side. And those 2 are in parallel, and they go to this one, which has clearly been reworked at some time in this guy's life. That is this big jumper that goes around to the what's marked as ground on this side, which is that pad there, which has a connection to some of the initial set of 4 transistors that we saw on the other side. All right. So looking closer at this negative side, I said there's the negative coming in, goes through these 2 transistors and is switched to presumably that one, but also goes to here, which is 2 of these 4 diodes down here, big honking power diodes. And the way 2 of them go that way and 2 of them go the other way, I'm going to guess that they are set up as a bridge rectifier. Don't know exactly why, and it's really hard to follow the traces on this double-sided board. But, those 2 are connected, those 2 are connected. So this is the output side of it, I'm guessing. Yes, it is. And where is that going? Oh, that's going to the transformer. So coming out of the transformer? Really? Because the input side of the transformer, I'm not going to completely reverse engineer this if you hadn't guessed already. I am just doing a bit of an overview. So I'm going to find out what some more of these devices are. These ones, these 4 here, don't really have any super high current tracks on them. That one's a little bit, so this one and this one are connected together, and these 2 are connected together. So all the transistors are operating in pairs. Let's find out what they are. I'm going to guess that one is either an N or an N channel, and the other one's going to be a P, NP or P channel. So these 4 over here are UF640L. That's these 4 on this end, which are not in a super high current situation like some of the other ones. And that is an N-channel power MOSFET, no surprise there. 200 volt, 18 amps, so it's well over spec'd for this purpose. And then these 4 here and those 2 on this side are all FTP08N06. Which is another N-channel MOSFET. These ones are only good for 60 volts, but they can handle 120 amps. Huh. I guess that makes sense. Yeah, they're on the DC, on the 12 volt side of the transformer, so they wouldn't need to be any higher than that. I wonder why they're all N-channel. I guess bill of materials cost, keeping that all together. But I would have expected there to be N-channel and P-channel in push-pull kind of configurations in here. It's a little surprising, but whatever. It's their design, and obviously it works. And it's not the best high current thing in the world. These transistors could definitely handle more current than what this design is pushing through them, but at least they're not overloaded. And The thing does shut down when it gets too carried away, so I guess that's good. Let's see what the smarts of this thing are. This one is a TL494G. TL494 is a pulse width modulation control circuit suitable for things like power supplies, AC to DC isolated power supplies. Also microinverters, or inverters like this in general, all sorts of things like that. Seems like the perfect chip for the job. And there, straight from the datasheet, is a typical application. The load is driven by these two transistors, an inductor, which I don't see any inductors in here cleaning things up other than that transformer, I guess. But yeah, there it is. Feel free to pause or jump to the datasheet yourself if you're interested in more detail. And the other chip is, oh, another one of the same, TL494. Okay. It looks like there's 4 transistors in the close vicinity to that guy. And the way they're lined up and as close as they are and what's going on, I'm going to guess that's probably an H bridge that's driving. Yeah, it looks like the traces are going off towards these transistors up here. So that's probably what is driving those guys to chop up the incoming 12 volts and jam it through the transformer. Okay, this is starting to make a certain amount of sense. And then I've also noticed down in here, there is an unpopulated header called USB. So that will probably be the 5 volts. And it looks like that the trace from the USB comes down across this capacitor for smoothing and is very, very likely somewhere on the pins for this, which goes up to this board here, which is where the USB connections are. Should we take a look at that? I don't think there's going to be anything on there other than just connectors, but just for completeness, we might as well. 3 screws holding that one in, and we have, oh, there's a lot going on there. Okay. So over at this end, we clearly have a couple voltmeter chips, but I can't pick up any, oh, wait a minute, XS-1 63580, and the same there, and each one has a 7805 voltage regulator flanking it. All right. Unfortunately, searching for that doesn't come up with very much. I've tried various combinations of permutations and can't come up with anything, but it's pretty clearly going to be a voltmeter chip, isn't it? Of course it is. My curiosity's got the best of me, so remembering that there will be live 120 volts on here, specifically on these 2 pins and other stuff in that vicinity, I want to see how the voltage gets up to here and what's going on, because it looks like there is the buck power supply up there. So I'm going to guess that we have probably 12 volts coming up there. And yeah, there it is. Okay. So that means that the buck converter is definitely up on here. Let's power this off before I get in trouble. Let's just see how long it takes for that to calm down. That's already down. That's good. That capacitor is discharged. Where's my other capacitors? There's one. That's discharged. That was one there. Okay, so we should be safe. Anyway, going back to what I was thinking about. So this over here is going to be a 12 volt to 5 volt conversion. I can't get any intelligence out of that chip, and I can't even see this one because it's hidden under that inductor. But it looks like we've got a little smoothing capacitor there, those 2 chips. What's hiding under that capacitor? Nothing, just a resistor. So that's what's going on up on this board. And I guess the only thing left to do is to test those USB connections and just see what kind of current they can draw. But I'm going to guess, since this is pretty typical of just standard USB charger. It's going to be in the 1 to 3 amps range probably. We do have some good beefed up tracks coming into it, so that's nice to see. I'll put this thing back together and test that out. I will be back in a moment or two. Alright, I've got it all back together. Powered on, seems to be working. We'll plug the USB tester into it and see what information we can get out of it. So that's telling me 4.9 volts, which is close enough. I'm going to draw 1 amp out of it. Yeah, that's close enough to 1 amp. Okay. Cranked up to an 1.75 amps, and we've still got 5.1 volts, so that's happy. There is 2 amps, and yeah, it's handling it all right. How about 2.25? 2.25 amps, and it's still holding 5 volts. Wow, that's surprising. Can we go for 2.5? Nope, didn't like that. So somewhere between 2.25 and 2.5 is where it conks out. And I guess based on what we saw in there, that's not unreasonable. That's pretty common for most USB chargers. Like this one that I was playing with earlier is 200 or 2000 milliamps, as is this one, and a lot of them that I find these days. So I guess that's not too horrible. I am quite disappointed in... Quiet you. I am quite disappointed in the AC current. It could only handle maybe 75 watts or less. And I am also quite disappointed about the waveform. Not even a 50-50. It's a 75% duty cycle square wave of all things. But, I mean, anything that's rectifying it, or these things that are just doing a DC to DC conversion anyway, it's probably fine. You wouldn't want to run motors on it, but then again, with that low current handling, you wouldn't want to run motors on it anyway. I don't know. For a thing that I got cheap at a yard sale, I guess it's okay-ish. I don't know what I'm going to do with it. It looks like it's reasonably built inside, minus a few chintzy things like these connectors and the hot glue holding them in. But I don't know. It's a reasonable enough thing, and especially for the price that I paid. But more importantly, it was just fun to take a look inside and see what's going on. If you got any questions or comments, throw them down below in the comment section. Thanks for watching. I always appreciate that. I'll talk to you later.